Well, welcome to this month's presentation, our webinar. The topic this month is going to be confined space training. My name is Ronnie Sexton. I'm going to be the presenter for this right here. And this particular topic is kind of a touchy little subject with me because the industry has been doing training. I know I've been doing training personally myself for over 25 years on confined space. And we're still seeing issues. We've got some of our member entities out there. They have policies and procedures, which they're not following. They have equipment, which they're not using. Matter of fact, there has been some fatalities that have occurred with some of our members that the equipment was sitting right out there at the location of the confined space entry on a vehicle not being used. And to me, that's a little hard to try to explain to somebody's loved ones and co-workers and family members and all of that, and how something like this can happen. So hopefully we can generate a little bit of interest today if you've not had any confined space training, and going a lot further. If you have had some confined space training, this is kind of a refresher and may touch on some topics or go into some areas that's not covered in a lot of classes and everything. So without further ado, let's go ahead and just move on into the program. Some of the topics that we're going to discuss: we're going to talk about the definition of a confined space. We're going to talk about identification of the hazards, understanding when permits are required, and we'll talk about basics of atmospheric testing and equipment, and we'll talk about some of the various PPE for safe entry. Definition of a confined space, and this is kind of interesting. If you go back years ago, NIOSH, they basically, and that's NIOSH, is the National Institute of Occupational Safety and Health, they actually went back and looked at about 180 different confined space entries where there was fatalities that had occurred, and they were looking for common factors. And one of the common factors is there was a lack of people out there being able to identify what a confined space is. And without knowing what a confined space is, people were going into confined spaces and subjecting themselves to the various hazards and not really realizing they were in a confined space. So we're going to start with a definition of a confined space. And first of all, it just has to be large enough for an employee to enter and perform assigned work. Now, in a lot of your the entities out there, one of your more common confined spaces is just going to be a standard sewer manhole. But then you've got your lift stations, you've got meter vaults. There's a lot of different type of confined spaces, especially if you start getting into the water and wastewater treatment plants that we might have to look at. It's not designed for continuous occupancy. And if you notice the picture there on the right-hand side, it shows a person that happens to be inside of a tank, but notice it's an open top tank. It does not have to have a top. You know, if you're going into a clarifier at a wastewater treatment plant, maybe you've taken it down to have to do some work on some sludge rakes, or, you know, a surface water treatment plant in the sedimentation basin, or even in some of the upflow clarifiers at some of the various type of water treatment plants that's out there. A lot of those, they don't have a top on them, but you get in there, there's some of the hazards that we'll discuss a little later that really come into play. And last, it has to have a limited or restricted means of entry or exit. And notice the picture there on the lower right-hand corner there, where it shows somebody going into a manhole with one type of a ladder there. You have to look at restricted, and most of the time the general guideline, if the opening is less than 42 by 42, or it requires a ladder as a means of entry or exit. And one of the reasons about the ladder, it makes it very hard to get somebody out of there if something happens, if you're not using the equipment like it shows the individual there. It may be a little hard for you to see in the picture, but they are wearing a full body harness with a retrieval line, you know, that's attached on the back. And by going up and down a ladder, also you want to be an anti-fall retrieval. So if that individual slips, basically it's going to stop them within about, a lot of times, 10 to 14 inches. It has to meet all three of these to meet the technical definition of being a confined space. So you can think about some of the ones we touched upon, you know, the sewer manholes, the lift stations, the pump stations, and a lot of the different ones. But another one that's overlooked quite frequently is storm drains in the street departments, because you've got a lot of the hazards that we'll discuss a little bit later and everything that can be in those, that's also in some of the others. hazards associated with confined spaces. You've got atmospheric, and we're going to go into all of these in a little bit more detail. You've got physical configuration, you've got some other hazards that we'll talk about, and you've got human factors. And when you look, they all pose hazards. Now what we're going to do is we'll look at atmospheric individually. Now, you've got an oxygen deficient. That's when you have less than 19.5. Anything less than that there can start to cause some problems. Oxygen rich, anything greater than 23.5. Now, it's not a health hazard because of myself also being EMS certified. One of the major things that you do on the majority of the EMS calls, you'll put somebody on oxygen, through, used to be nasal cannulas, now most of the time it's a non-rebreathing mask, but you'll put them on oxygen because it will help. Unless somebody's COPD, it's going to help them. And a lot of times it just creates a calming effect, which will lower their blood pressure and their pulse rate, because they're starting to receive some kind of treatment and everything. And then you can get into the toxic, and we're just going to take right here and just a little simple breakdown of like a sewer manhole. A lot of your different toxic gases that can be in there. One of the ones, methane, it's going to be right at the top. If you've got the lid on a sewer manhole, and a lot of the ones that kind of cut down on the I&I problems out there, they put the little plastic, what a lot of people call dish pans underneath there. I know they have the little vent, but you get a little road slime and some rain and mud in there. It kind of covers the vent up. And to me, when you've got a situation like that there, it's kind of like sticking a cork in a bottle. The sewer manholes have little holes or vents in them, and sometimes we will plug those with some bolts and everything. But with that I&I pan in there, you're not allowing some of this to escape. Methane being lighter than air is going to be one of the first things that comes out of there. And I jokingly talk about a lot of times in some of the training classes I do, this might not be the time that you might want to be smoking. Because methane is highly flammable and everything. And methane is one of the major byproducts of the decomposition of organic material, which you do have the organic material in wastewater, but I talked about a while ago about the storm drains. Think about the organic material in there. You've got the limbs, you've got the leaves, you've got the grass clipping, you've got the frogs, the various critters and all of that. And all this decomposing, you can have a lot of the same thing, that may show up in a storm drain. Next one is your hydrogen sulfide, or H2S. That is another byproduct of the decomposition of organic material. Propane. And one of the reasons that propane is listed there, propane being roughly 2.5 times heavier than air, it is going to settle into low areas. So if you had a propane leak from maybe somebody that had a propane storage facility, or maybe they're using propane rather than natural gas, and we do see that in a lot of areas, in some of the newer subdivisions and everything that's popping up, is they don't have natural gas. I know my stepson right now is looking at building a house, and they've got an option, go all electric or go propane. But the thing about it is, because of the HOA, they want the propane tank buried. Well, he lives in an area that is predominantly rock, and to blast out a hole large enough to bury that's very expensive, so they're going to go all electric. Gasoline. You may be around an area where maybe there was an old gas station, maybe the underground storage tanks haven't been dug up, maybe they've rusted through because maybe the tanks are old enough, they're still the old metal tanks, so you could have the possibility of gasoline being in there. So you just take a standard sewer manhole, and then once again, like I talk about, what is somebody pouring down a sink at home right now? What is some business possibly dumping on you? Think of like a high school where they've got a lab class, or possibly college. What's somebody pouring down a sink? That's going in there beside all of this right here. So when you look at the toxic, there's just a lot of problems that can really come from those. And then you get into the flammable, and you notice there the red area. And that really varies. I know I was just in a class on Tuesday where they was talking about some properties there. And you take like natural gas and propane, some of those, a lot of times you'll see they have a flammable range from about 5 to 15%. But there was another one we was talking about hydrogen and everything, it goes from 2% to 70%. So you can see that upper flammable limit, or you may see it as upper explosive limit, the UEL. if it will, if it will burn, it will explode. And then you have your lower. And as long as it's below the lower flammable limit or lower explosive limit and everything, it's too lean. It's not going to ignite. Now, if you notice right at the bottom, maybe a little hard to see on your screen, a little green area there, that's 10% of the lower flammable or LEL. That is the level that the monitors are to be set up to detect that, so that you can catch it before it even gets into the too lean. We want to catch it in plenty of time where we've got something to do with it. The next area there is we want to look at physical configurations, because a lot of times that's going to play a pretty important aspect. Just a lot of different things there. It kind of kicks in. I'm going to go ahead and bring the pictures up, and then we'll come back and talk about it. But your physical configuration, that can be a problem as far as allowing easy access. You see that in the center picture. Over on the left-hand side up there, it may determine on what type of equipment you have to have. And even in some instances out there, in some of your larger cities, you take like in the Dallas-Fort Worth area or even here in Austin, there's a friend of mine that used to work for Austin Electric. He said downtown they had some electric transformer vaults that were underground that actually caused them to have to get some additional retrieval winches and everything, because the depth of them exceeded the normal length of cable that comes on most of the manufacturers. So just a thing to take into consideration there. The physical configuration, the picture on the upper left up there shows, a 4-foot diameter sewer manhole, there's not a lot of room inside of there. Even sometimes with some people that's a little tall, bending over can be a little bit of a problem. In your pictures down in the bottom there, your lower left-hand corner, just showing where there's a level in there, and then there's some pumping that goes down to a wet well side. Over on the lower right-hand corner, you've got a picture there, that shows a pump station, with some liquid that has leaked out inside of there. And then even in the middle there, a lot of times when you get some of your testing equipment that may be inside of there that's monitoring your flow and just a bunch of other equipment that's in there, it starts to make it very hard to move around inside of there, bend over. But these also become entanglement or entrapment hazards, that can be involved in there in case a person goes down. That even if a person's wearing, like in the top row, the middle picture there, once again where this individual's wearing a full body harness with a retrieval, if they was to go down in the picture right underneath there or over in the right-hand corner, there's a lot of things that possibly an arm could get hung up on, a shirt could get hung up on, even the harness, which could make it very hard to get somebody out from there, which would possibly generate the need for having somebody else out there that's serving in an attendance position that is geared up to where they can go in there and safely remove the entanglement or entrapment hazards, possibly to be able to remove them to get them out to safety. So, physical configuration. I can remember years ago doing some training. There was a larger city street department. This is before they really started running the TV cameras like you run through the sewer manholes, running that through the storm drains to look and see on some problems where there was damage, maybe a joint had started to come apart and just causing a lot of problems. They were actually sending workers through there. Then you've now transferred from a vertical type that's most common to a horizontal type entry, and that changes some of the equipment that you need. So physical configuration can play another important role on what type of equipment you need. There might not be enough space for a person to go in there. If there's atmospheric hazards and they're having to wear an SCBA, it might generate having to go to a airline supplied respirator with just a little escape pack to cut down on the size that it's taking up to allow the worker to be able to move practically around inside of there to be able to do their job. And then hazards, other types out there. Just some of the pictures, and I'm going to go ahead and pull up the pictures and then we'll kind of talk about the different ones and everything, is, just in the upper left-hand and right-hand corner, once again, it's pumps, motors, just a lot of the other stuff's in there. The way that they're raised up can create a lot of problems in moving around, which creates some entanglement. But one of the main hazards there a lot of times is you take an electric motor that's running, driving a pump, you're going to have a lot of ambient noise inside of there, which is going to make it a problem communicating, especially by voice with somebody outside. Also, in some of these, without some good ventilation, you take in the summertime where you've got an electric motor that's running under load, you can see ambient temperatures in some of these on a 100-degree day. You can see ambient temperatures in a lot of literature that I've read and tests and stuff that's been conducted. You can get up to 140, 150 degrees. So now you're adding another potential hazard in there of the possibility of heat-related problems of a person just going down from, some of the heat-related problems from, just fatigue, exhaustion, all the way up to heat stroke, and heat stroke can be very deadly. So, watching that also, a situation with that, a lot of times, if somebody is in pretty good shape and they've been pretty well hydrated, what a lot of people won't realize is they will keep going and the body temperature will start to go up. And once you get a core temperature and your blood starts getting up high enough in temperature because of the ambient temperature around there, you can start causing some damage to some very critical organs, starting with the brain. You can get into the kidneys and all of that. So there's a lot of factors that can play in there. Now, the center picture there. If you've got electric motors in there, then you may have some breaker boxes in there. You've got a lot of power coming in. And one of the things that I've really noticed in the change in my years, which has been a pretty lengthy career, and we're not going to get down into exactly the number of years and everything, but I can remember when a lot of the motors were 120 volt. Then we went to 240 volt. But you're seeing a lot of the motors now out there is 480 volts. And folks, let me tell you one thing about 480 volts. It is a lot more hazardous to deal with than 240 volts. Matter of fact, even a lot of times people recommend that in 480 volts, you need to even start to kind of take into consideration humidity in the air, because that will allow a little bit more of an arc factor. So in working without turning it off or having proper, in most cities, people are not trained to work with rubber gloves. I know we had a person who got pretty severely burned a few years ago that was a journeyman electrician working for a city. A journeyman electrician means that person has been in the industry, in electrical, has worked underneath, a licensed electrician enough that they have gone through the first level of certification, is dealing with some voltages and everything without gloves, and got pretty severely burned. Not too long after that, another person got into it, and it was actually bad enough that it put them into cardiac arrest. And fortunately, that the emergency responders were able to get there and get CPR started in less than a minute. And then what I was told, when the fire department, which happened to have EMS, got there, they defibrillated twice before they got the person back. And, kind of a general rule in EMS is a lot of times you'll defib 3 times, and after that, it's kind of questionable. You may contact medical control, and they may ask you to run a 6-second strip. And if there's no indication of any kind of pulse and everything, they'll call you right there on the spot. So what I'm saying, that individual there was knocking on, almost not going home at the end of the day. The 2 pictures on the bottom left and right hand corner, a lot of times work activity that's taking place in there. You may be doing some grinding, you may be doing some drilling. Over on the left-hand side, it looks like somebody's doing some arc welding there, but I know in the past, I've actually gone into a commercial meter vault where the bolts on the meter were so corroded and you really couldn't get anything in there to cut them with. Well, we took a torch in there, but we're testing the atmosphere, we're doing a lot of ventilation and everything, but the only way to get to some of the bolts to be able to cut it to change the meter out was taking a torch in there. The middle picture there, it shows, looks like steam lines because of the way that they're wrapped in an insulation. And then once again, you have to look at that. It surprises me in how many cities that we still have that have boilers and are using steam radiant heat in some of their old buildings. They just hadn't changed them out. And a lot of those being that old, the insulation wrapping, probably asbestos. So, you've got a hazard there. You can have hydraulic lines in there. You can have electric lines. You can have communication lines that you've got to be careful about. Not so much from the shock hazard, but just the fact of doing damage to them. So there's just a lot of other hazards that can be in a confined space because of what's necessary, to be able to operate the various different type things that we have within our cities or other entities out there. Human factors. Bring the pictures up here and I'll kind of talk roughly about those, but there's some human factors. Now, I'll start out with the one on the top row in the middle. That is a confined space. That's one of the older type water towers. A lot of those are been pretty well taken out of service now, because if you actually go back, those were actually paraffin lined or coated inside to help seal the metal and keep it from rusting so bad. And then as it come about, and trying to get rid of that. But I don't know about some of y'all out there, but I really don't like heights. Now, to allow me to climb up there and take a rope and rappel off of it, that's one thing, but to go up there and work. And I also found out it's worth the extra money to buy the long life aviation light bulbs to put up there, because it reduces the number of times that you may have to climb those towers or promote up to where you can have somebody else that fits their job description. So, there's a lot of factors that you can take in the human factors there. Might be an incentive to try to advance your career to get out of that position. Over on the left-hand side there, you've got some people that's going through there, look like they're doing some surveying. I don't know whether they're GISing or maybe they're looking to see, flow, just a lot of different factors inside of there. But that's starting to get a little cramped because you've got a water level that's running through there. So they start to eat up a lot of the space. Over on the right-hand side, you've got a couple of workers in there, and you can kind of see this one's large enough, that they're kind of setting, inside of the pipe there. The bottom left-hand corner there shows you going in and out of a ladder. Well, a ladder starts to eat up some of the usable space going in and out. The center picture, the rescue aspect, and having been in the volunteer fire service 36 years actively, but still doing a lot of training, having made one confined space rescue, but doing a lot of training on it, a lot of times, and I know in some of the training that I've done, is sometimes some of the mobilization devices that you would use for patient packaging to try to get somebody out of there that's maybe fell, broke a leg or an arm, or just concerned about some injuries and everything, it can be a little hard. I know being a patient judge evaluator in a confined space rescue competition several years ago, that was a lot of the problem. The people that were packaging me, the way that they were packaging me, I'm sitting there looking at the opening that they're going to have to take me out. I'm not going to fit. And so, they spent about 10 or 15 minutes getting me packaged to raise and find out, okay, that wasn't going to work. Or what if it had been some kind of life-threatening injuries? So, there's a lot of factors that involve in there. Then over on the lower right-hand corner, there are a lot of times, here you've got line of sight where you're able to see. A lot of times that's going to be able to work if there's not a lot of ambient noise and everything. You can use voice communications. Notice the person standing on the outside has an atmospheric tester there, so they're constantly checking. So let's talk about some other factors. We talked a little bit about temperature. That can be a problem. Temperature, naturally, the body's trying to cool itself, so you're going to see pulse rate go up. A lot of times when pulse rate goes up, you're going to see blood pressure go up. Some of your older workers that might be on some blood pressure medications and everything, the heat and the increased blood pressure can cause some problems there. So that is the concern, keeping your people cool, keeping them properly hydrated, watching them and everything. And we've got to be careful about asking people about health-related problems because of HIPAA, but hopefully that the individual understands enough about their safety and everything that they will be forthcoming, but we cannot pry that information out of them. So that kind of, that's a little bit of a slippery slope that you've got to be kind of careful with in today's legal liability world that we deal with. The other area is claustrophobia. Here's what I've found in doing a lot of SCBA training in the fire service and everything. A true claustrophobic, you're not going to get them in a confined space. The problem is, if you read a lot of the literature from the, psychologists and psychoanalysts and all those type people and everything, they say that everybody is claustrophobic. And the problem about it is a lot of times it will be a space that you've been in before. But today, there's something going on up here. You're thinking about something else, and all of a sudden you realize your pulse rate is up. Well, what's causing my pulse rate to be up? Well, now anxiety kicks in. And once the anxiety kicks in, it's going to do what? It's just going to elevate the pulse rate. Elevated pulse rate's doing what to the blood pressure? It's raising the blood pressure. And all of a sudden, a lot of times you start sitting there and you just freak yourself out. For lack of a better word, you just freak yourself out. And you come to the conclusion, I've got to get out of here. Now, here's what I found out. You do not want to be between that individual and the way out, because somebody's going to get hurt, and it will probably be you. So it's just best. And to me, that's the reason I believe in realistic training, because I would rather find out in a controlled environment that somebody's going to have a problem. But then you're not going to be able to catch all of those, because if something's going on in Ronnie's mind today, and he's off down in there, and this is a space that Ronnie's been in 10 times before or 100 times before, but something's going on up here today, you can't train those type of situations out. The only way you can train it is try to get Ronnie to tell whoever the person is that's attendance outside is, I need to come out. And that should be the end of the discussion. I have told that person I need to come out. That's what we do. We get Ronnie outside, and we try to get Ronnie settled down. But a lot of times, oh, it's not that bad. Settle down, all that. Look, you're outside, I'm inside. I'm the one that's having the problem. Let me get outside. And so, it's just a lot of factors that kind of play into this. Permitting. And I like to change the word permit to checklist. And we actually have a sample and everything that if some of you are interested in everything, if you will send an email in to my email, and my email address is just rsexton@tmliorp.org, or you just send it to somebody and get it to the loss prevention department. Either myself or your loss prevention rep, we can get you a copy, of a checklist that we have put together. And I'm a firm believer that a checklist is required. Because a lot of times we get mad, we get aggravated, it's hot, it's late in the day, we got other activities, we don't want to work overtime, we've been called out at night. We get in a hurry and we overlook that little step that could really be the difference. So a lot of times just going through this checklist, just to make sure. Now, there is some that if you look at the industry standards out there that stipulate that has to be. One of them, a hazardous atmosphere. And notice it says contains or has the potential. Well, let me tell you something. If it has to do with wastewater or storm drain, there is a potential there all the time. I've jokingly said all it takes is one flush of commode and an atmosphere has changed with inside a sewer manhole or something like that there. So that is an area where a permit is required so that you go through the necessary steps. The next area that you're going to see, potential to engulf an entrant. A lot of times if you're in an area, you have to realize a lot of our confined spaces, the most common one is a sewer manhole. Now I will say this here, because of changes in a lot of the equipment that we use. I can remember in the old days when I first started, rodding a sewer manhole, that's exactly what you did. You went down in there with some sectional rods, you shoved them in the sewer line, you clipped another one together and you shoved. It was called manually rodding. Then we went to the mechanized. Now we have the sewer vacuum trucks where we pull up there. We've got the jetters and everything. We have engineered out by a lot of times by some of the equipment that we're using, a lot of the lift stations, now the control panels, the electric motors, and even some of the pumps are basically located outside. So we have eliminated a lot of that. But if you have to go in there, you have to take into consideration the potential for an engulfment. That's actually caused one of the last fatalities that we did have in a confined space where a person went in there and removing a sewer plug, caused on the upstream side, caused a sudden rush of water in there, which basically caused the person to become entrapped. And I'll say part of that has to do with the size of the line. I think his foot got pushed back up in there, and with the flow of the water and everything, he just couldn't work his way out. And basically, he become a plug on the downstream side, and what happened is the hole filled up and the person drowned. Equipment was nearby that would have had a harness on there that could have retrieved the person, and we might not have been talking about a fatality. Internal configuration. It shows the one there, and yes, Round Rock gets a little extra advertisement out of this right here. I don't know if that's over there by the Round Rock Donuts and everything, but that is an old tower. Matter of fact, I think it may physically still be there, but it's not involved in the system. But we used to go up there and we had to do annual inspections, and that usually meant draining the tank and going down inside of there, doing some checking, taking some pictures, looking to see how the paint, any corrosion. And then once we came out, we filled them up with usually about 50 parts per million, high concentration of chlorine to disinfect it. Well, the problem was, what was we doing with that high concentration? We were dumping it out. And it was going into the storm drains, it was going into streams and everything, and it was creating some environmental issues. So now if you dump it, you have to go through a way where it reduces the amount of chlorine. And then it come about, a very common method that was being used was to put divers down inside of there. Well, then I talked to the fire departments. Now you've got a high angle confined space dive rescue. So that starts to create a lot of problems. Where they put on an encapsulated suit, they spray some chlorine on there, they can go in, they can take the pictures with some testing equipment, they can measure the thickness of the paint, they can do video and all of that. Okay, now they've got to the little robotics. Now they go up on top, they sit up there with the little joysticks, and the little robot swims around inside there and does all the measurements and everything. So once again, we have engineered by different methods and different tools that's being used some of the confined space entries. But the internal configuration, because of the bowl or the sloping floor, that causes a problem. A person could slip, fall over there where the riser pipe comes up. Well, most of the time it's supposed to stick up about 18 to 24 inches above where the bottom comes, where a person can't really fall off in there. And then the last area is kind of a catch-all that's put in there, any other recognized safety hazard we can, and where I talk about a lot of the ones here. Okay, it shows the person welding, cutting, grinding. A lot of times there are the heat-related problems, but I want to talk about another one, okay? We're in the winter time, we're fixing to go into the spring. What about ice? What about rain? What about mud that can get on your shoes? Trying to climb a ladder, that creates a problem. So a lot of times you can have slip, trips, and fall hazards just because of the environment, of weather-related things. I'm not saying that really requires a permit, but it just means that we need to be for sure that we've got our eyes open to the hazards that's taking place out there, that could cause it to turn out to be a bad day for either yourself or some of your coworkers. Atmospheric testing. It's an evaluation of what kind of problems were there. And folks, I want to tell you this here. If you're not tested, you don't know what you're going into. I cannot put it any simpler than that there. What you really don't know is if I go in there, do I stand a chance of coming out? And that can be a problem. Duration of the testing. This is where you need to become very familiar with the various meters out there to be for sure that you have left, especially if you're using a remote sampling hose, that you have left it in there long enough. Now for the duration, we want to do the testing, everything, from before we put somebody in there to after they come out, because it can change with somebody down in there. Testing stratified atmospheres. You're supposed to test at no more than 4-foot increments. Vertically, because going back to the drawing earlier, it showed you like the methane up at top, then it showed the H2S, then it showed the propane, then it showed the gasoline. It can be stratified in there. And even when you open the top of the manhole, you're not really getting much of a ventilation effect. Only ventilation you're getting there is just a temperature differential between the air inside the space and outside the space. And once it equalizes, then any air movement has really stopped. So if you've got something like your H2S, it's going to be sitting right down there on the bottom. Methane's coming out the top. Order of testing. We want to test, and the meters are going to be doing them all. Is the order of testing still left in there when used to you had to turn a switch to, okay, I want to test for oxygen. Why? Because I need oxygen to live. Then we want to test for flammable. Then we want to test for toxics. And so that used to be the ordering. With the monitors now, they're testing all of them and giving them readings, but that's where that comes from. Other important information. What do the numbers mean? If you don't know, what's the permissible exposure or the permissible limit that I can be exposed to of, say, carbon monoxide? Because most of your monitors are going to test for oxygen, going to test for flammable, carbon monoxide, and H2S. How much carbon monoxide? Because we're out here working beside streets. There's cars coming up and down the road. There's going to be carbon monoxide. How much can I be exposed to? If you don't know some things like that there, then what are the numbers really telling you? And so that's the reason it goes a lot further than what we can cover in just this little short webinar that we're doing today. So if you don't understand the permissible exposure limits, and you know, I kind of joke on about those, and I'm going to tell you, you know, on carbon monoxide, you know, the industry experts out there says that Ronnie can be exposed to 35 parts per million for 8 hours and should not suffer any adverse health effects. Now let's break that down real slow. It says the average individual. Well, who is that? And if there's a group of you watching this, look around the room and pick out the average individual. It doesn't say height, it doesn't say age, it doesn't say weight, doesn't say gender, doesn't say race, religion, ethnic background, all these things like that. It says the average individual can be subjected to 35 parts per million for 8 hours. So does that mean 7 hours and 45 minutes is okay? And should not suffer, should not. That's kind of a maybe so, maybe no. Any adverse health effects? Okay, what's an adverse health effect? Am I going to go blind? Right arm going to fall off? Am I going to, you know, have an upset stomach or something like that? What is, and you'll put, if somebody says that real fast, a lot of time we just go, okay. So, you know, this is where sometimes you really need to break down some of the stuff and really fully understand what it's saying. Types of testers. You may have some fixed ones. A lot of times you'll see that in some of the chemical buildings at a treatment plant. Most of the time, you're going to be using a portable type. Inspection. That's just simply, does it look like it's all there? Well, if you hadn't had training, you might not know if it's all there or not. Does it look like it's damaged? You know, what's the condition of the battery? How much battery life is left? So that we don't go out there on the job site and get out there and the battery go dead. What are we going to do? Are we going to turn around and come back to the shop or service center? Or are we going to stay out there and try to finish the job when we have no monitor telling us what's going on? That's what's got a lot of people in trouble. Calibration. Let me put this as simple as I can. Calibration tells you, is that meter telling you the truth? And if my life depends upon that meter, I want it telling me the truth. So when was the last time it was calibrated? How often does the manufacturer say it needs to be calibrated? Just because, you know, it's been sitting up on a shelf and we hadn't used it, manufacturer will list a time period in days. It may be 30 days, it may be 90 days, it may be 180 days, maybe even a little bit longer than that. But they're going to tell you a certain number of days whether or not it's been turned on or not. A function test. That's just kind of be for sure that the alarms are working. Just a simple way you can do it, you can breathe onto the oxygen sensor. We exhale at roughly 16% air. It's supposed to alarm at 19.5, so it will go off. If you have, or you're around some of the dry erase magic markers, they have a high content of alcohol. That will cause the flammable to go off. On the carbon monoxide, don't take it and stick it over there by the exhaust of the truck, because the concentration will be too high and you'll wipe out a sensor that may cost a couple to $300, and that will probably result in an interesting conversation with your supervisor. And then use. Just some of the things about using it, especially if you have the remote sampling hose. Just a lot of factors about it. But a lot of times somebody gives it, you know, tells you, hey, push this button, it's going to beep, chirp, and everything, some numbers will come up, that's all you need to know. No. You need to know a whole lot more than that, because remember, your life depends upon this machine being calibrated and giving you the truth, but also you understanding how to use it. Some of the PPE, I'm going to put up some pictures up here. Right there, we have the tripod. Most of the times, those are going to be aluminum legs. They may be rectangular, they may be square. Over in the next picture there, just shows one of the mechanical type harnesses there. There's a couple of types down below. It's the one up on top is a work positioning anti-fall retrieval. The ones down on the bottom down there, those are anti-fall. In other words, they will stop you. Some of the ones you can get will have a fold-out handle on those, is where they're an anti-fall retrieval. If you've got somebody down in there and they slip and fall or they go down, you can just fold out the handle and you can crank them out. The one up there in the upper right hand, that is a work positioning. If you do not have a ladder or some other and I have to raise it and lower you, it requires that type. You may need some other protection in there. If you're working where possibly some wastewater could splash on you, you may need a full protective suit, eye protection, gloves, just a lot of things, the rubber boots, the goggles. Earplugs, a lot of times just because of the ambient noise that might be from some electric motors or pumps running in there. And like a lot of times the pumps, they'll get a little whining noise to them. So you take that along with the sound of electric motor and all that, ear protection. Now, what's the problem with ear protection? That makes it a little hard for us boys to communicate with somebody on the outside. And unfortunately, some of the times, that's some of the things that we have to look at is, well, I'm not going to wear the ear protection because I can't hear somebody hollering at me. Well, later on in life, you might not be able to hear anybody either. So, you're going to have to make a decision. Sometimes a hard hat and working below grade, if somebody outside drops something, or a lot of times it may just serve as a bump cap. But to me, I'd be more concerned about somebody possibly dropping something outside, falling a few feet and hitting you on top of the head. You've got your full body harnesses. A lot of times this is the problem that I see with them. They have a date tag on there. Most of these have a lifespan from date of manufacture to expiration date of 5 years. You may have only had it 18 months, but it might have been 3 years since it was manufactured. So you're only going to, you've only got about 6 months left. It has an inspection tag on there. A lot of times some of them are required to be inspected monthly. Most of the times when I look at a tag when I'm teaching a class or doing some type of inspection or something other, I may see one that's expiration date is gone and it was never inspected during the 5-year time period that the city had it, whether it had to be inspected monthly or quarterly. That can be a problem if something goes wrong. Then you may get into the different type of atmospheric testers. I like somebody that's testing outside, but also like one on me. Then you get into the respiratory protection. You've got just basically the air purifying. Then you've got your SCBAs. Like I said before, a lot of times the problem with the SCBA is being able to get in and out of the space. And then here's a picture of the air supply for an airline supplied. And then we may get into ventilation, which we'll talk about there on the ventilation, the ventilation and everything. A lot of times what you're trying to do there is there's an atmosphere in there that you're trying to reduce it down into a more safer level and everything, but you want to be for sure that you're still monitoring the air to be for sure that the ventilation is not picking up contaminated air. A lot of times the exhausts of a pickup or 1 ton or maybe even some of the traffic and everything. So that covers your PPE. Loss prevention services, we do have the online learning where you can go online and a person can sit at a computer and can do this at their own pace. We have the training programs. You can go to our website under loss prevention. You can look there and see a little short analysis of the training programs. You can look at a training calendar and you can register for the programs. And then we have an electronic media library that, to me, I don't know why more people are not using it, because so many people say, well, the training classroom, we have to try to fit that around y'all's schedule. You can check out the DVDs and everything. You can work the training around your schedule and everything. So there's a lot of loss prevention services out there, that we do. Myself as one of the trainers or your loss prevention reps. Hopefully we've been able to share some tips with you today about confined space training. Y'all be careful out there. Thank you.